In this orthokeratosis case, we're working with a patient who's a little bit undercorrected after treatment and also has some residual astigmatism in the post-treatment refraction. If we look at the topography, we can see that the landing zone can be tightened a little bit, but this lens is also decentering slightly inferiorly. And usually with a low writing lens, what we want to do is loosen the periphery, so we're a little bit at odds in terms of what changes to make to this lens. But let me bring up the lens and maybe offer a few suggestions. So here's the lens that the patient's currently using. We can see what appears to be a pretty large amount of central clearance, and that's because we tightened the periphery on this lens one time already. I think your recommendation of loosening a little bit at the edge of the lens is pretty good. So I would go ahead and decrease the sag here about 10 microns, so we end up with about 1843 in this case, and we can do this at 100% mode. And if we look at the patient's refraction, there's a diopter against the rule that is still there after treatment. The cornea is about a diopter with the rule, however. So this patient's got about 2 diopters of internal astigmatism, and what we want to do is have a little bit less molding in the vertical meridian. So in 50% mode, what we can do is loosen the entire landing zone here, go maybe 15 microns, and a little bit less molding the vertical meridian should help us get closer to a spherical endpoint. So from 689 to 674. And then we need to do the same thing in the inferior quadrant since we're in freeform. 701 will be at 686. Okay. So hopefully flattening the lens in the vertical meridian will also work in our favor in terms of drawing the lens upward a little bit and get that treatment zone to center over the pupil a little bit better. With a change like this, what I've been doing recently is adding prism into the lens. Don't enter any refraction, you can just enter prism. And we'll be able to see the prism ballast that the software puts in there. And what I asked the lab to do is drill or dimple the lens at this location and dot it. That way we can see how the lens rotates on the eye, and the patient can also look in the morning when waking up to see if the lens is still oriented with the dot at 6 o'clock. If we make changes to the lens that are meridian independent or meridian dependent, and the lens rotates, then we're going to get a result that's sometimes opposite of what we want. So I like doing this. It just helps me to, it's not a guarantee that's how the lens is on the eye when the eye is closed, but it does give me an idea whether a lens is going to move to the position that we anticipate. So hopefully you'll find these thoughts helpful, and best of luck with your patient.